Hi students, very good morning to everyone. Today we are going to discuss our subject of metal cutting and machine tools unit 3, and the today's topic is completely related to the planar machine. Okay, so as we have already discussed about the shaper machine and the slotting machine, now we are discussing about the planar machine. Okay, so what is a planar machine? A planar machine is a machine tool primarily designed to produce planes and flat surfaces by a single point cutting tool. So what is a planar machine? A planar machine is nothing but it is also a machine tool unlike a shaper and a slotting machine. Why it is used? It is used to design or produce. It is used to produce the planes or flat surfaces. So what is the cutting tool that we are going to use? We are going to use the single point cutting tool only. Okay. Next, a planar machine is also just like a shaper machine, but it is very large and massive, and it is capable of machining heavy jobs which cannot be done by the shaper. Okay, so we all know the working of the shaper machine. Okay, like the shaper machine only, the planar machine is also it's working, but it is very large and massive, and also it can do very heavy jobs that cannot be done by the shaper. Okay, you can see the main difference between the planar and shaper is that in planar the work is loaded over the table and reciprocates past the stationary cutting tool, and feed is given by the lateral movement of the tool. Okay, so the major difference between the planar and the shaper is, in case of the shaper, the workpiece is in movement, but in case of shaper, the cutting tool is in motion. The workpiece is stationary, but in case of the planar, the workpiece is in motion and the cutting tool is stationary. That is the major difference between the planar and the shaper. What it is? Here you can see the work is loaded over the table and reciprocated over the cutting. In shaper, the ram holding the tool reciprocates. Okay, you can see the difference. In the shaper, the tool is reciprocating over the stationary work loaded. But in case of the planar, the work is reciprocating. Okay, that is a major difference between a planar and a shaper. So next one is planar machine main parts. These are the main parts of the planar machine. What are they? It consists of a bed, table or planten, housing or column, cross rail, tool head, driving and feed mechanism. Now we are going to discuss about these parts in detail by using of an animation. Okay. So now we are going to discuss about the constructional details of a planar machine. So first one here, it is the bed. So this is the bed. So on this bed, it is a rigid structure. The structure that is used for the planar machine is mounted on this bed. So generally this bed is made up of cast iron. Okay. So the next thing that is being put on the bed, you can see from the animation over there. So attached to this bed we can say it as housing. Those both are the housings. Okay, those both are the housings. Those are can also be called as columns. Those are the vertical structure that are attached to the bed. So on the top, in order to balance them, we are having an overarm support that is attached in order to balance both these housings. And next one is a cross rail. Next one is a cross rail. Okay. And attached to this cross rail, we are having this work tables. They are tool holders. We can say it as tool holders. So these tool holders are kept in vertical in direction, as you have seen, as I am showing through the mouse over here. Okay. Generally 4 tool holders are kept, and we are going to use the single point cutting tool for the process of the operation. You can see it can after fixing, these can be moved in either left or direction. Before fixing, they can be moved in the left or right direction. As I said, we have totally 4 tool holders. Okay, 2 are attached to this cross rail and 2 are attached to the house. So what happens here is, here you going to use the single point cutting tool, and these single point cutting tool, these are called as I said, side tool posts. And on the top of this bed we have a table. On the top of this bed we have a table. On this table we are having the workpiece. Okay, on this table we are having the workpiece or the job in which the operation is to be done. Okay, so this is the front view of this construction details of a planar machine. If we can see the side view, we can understand better. Okay, on the top of this table, as I said, a work is been supported. That is the work that is been supported over there. Okay, so if now we are going to see the side view, we can see. Now we will see the side view. This is the table, as we have already known. As this is the table. To this table we are having 2 housings. Housings are column. We can say either housings or columns. And to this, as we have seen earlier, we have a overarm support. We have a overarm support, and under that we are having a cross rail. Under that we are having a cross rail, and we are having tool posts. We are having the tool posts that they can be called as sliding tool posts, and these are the single point cutting tools. These are the single point cutting tools by which we can perform the operation of removal of material. See, these 2 single point cutting tool are attached to the tool posts. The single point cutting tools are attached to the tool posts. So whenever we are placing our job on the table, okay, the table reciprocates. The table reciprocates, and when the table is reciprocating, the job that is placed on the table gets engaged with this cutting tool, that is the single point cutting tool, and thus the material over here is removed. You can see here I am moving the table, and likewise I can fix that sliding tool posts. Okay, in once I fix them, I mean these sliding tool posts initially, before the fixing of the job, they can be placed according to the job. Once these are placed in the proper, once these are placed in the proper position, okay, position, our work or the job can be done. Okay, so you can see here the various parts as we have discussed here. You can see here. So what we have discussed various parts are, this is a bed, okay, this one and this one are the housings, and on connecting to this we have a overarm support, and below this we have a cross rail, and in this cross rail we are having this slide tool posts. Total we are having 4 slide tool posts, okay, and to this slide tool post the single point cutting tool is attached, okay. On the bed we are placing a table, and from the table, on the table we are placing a work or a job that is to be performed. Now what we are doing here, we are just reciprocating this work. Whenever we are reciprocating this work, as we are having this single point cutting tool over in this tool post, the single point cutting tool is completing the job, okay. You can see here in the side view also, as I have already shown. So table, housing, overarm support, cross rail, sliding tool. This is the table, this is the housings, this is the overarm support, this is the cross rail, this is the sliding tool post, and this is the single point cutting tool, okay. Until now we have discussed about the various parts of the planar machine. Now in order to understand what is the mechanism or what is the working procedure that is happening in a shaping machine, we should understand them in detail, okay. Planar mechanism, okay, this is the, that is the work table, and on the work table we are having a workpiece, and on the workpiece we are having a single point cutting tool, and the single point cutting tool comes in contact with the workpiece, and the table is reciprocating, and the cutting tool is stationary, and the material is been removed. So in order to understand this planar mechanism, we need to understand the different kinds of drives, okay. Generally the driving mechanism of a planar machine. Now we are going to discuss about the driving mechanism of a planar machine. So what is the driving mechanism? How the table reciprocates. So first one, I have placed a counter shaft, and to this counter shaft I have attached 2 pulleys, okay. One small pulley and second one larger pulley, and on the other end I have attached another pulleys, okay. And at the bottom I have a shaft. To this shaft I have attached 2 pulleys, 2 larger pulleys and 2 smaller pulleys. So you can see the color in the blue, okay, that blue color pulleys are called as fast pulleys, and you can see how these are joined. You can see here the blue color are attached, and the red color pulleys are called as loose pulleys, okay. Generally the blue color pulleys are attached to the shaft, and the loose pulleys, that is the red color pulleys, in this diagram for our reference only we have taken the colors, are not attached to the shaft, they are on the top of the shaft, okay. You can see here. So once again I am repeating it because it is very important mechanism. See, this is a shaft, right? To the shaft we have 2 pulleys over here, 2 smaller pulleys and 2 larger pulleys. On the other end I have 2 pulleys. This 2 pulleys acts as a counter shaft, okay. And in the bottom I have a shaft, and this shaft, it is these are bigger pulleys and these are smaller pulleys. So we have totally two kinds of pulleys here. What are these two kinds of pulleys? One kind of pulley is the fast pulleys, which are blue in color here. Second kind of pulleys are the loose pulleys, which are red in color. So what is the difference between these fast pulleys and the loose pulleys? So these fast pulleys are connected to the shaft, but the loose pulleys are not connected to the shaft. They are on the top of the shaft. So you can see here. So these pulleys, this smaller pulley and this larger pulleys are connected by a belt drive. That belt drive is called as cross belt drive. So why it is called as cross belt drive? Because if I am rotating the smaller pulley in the clockwise direction, this larger pulleys will rotate in the anti-clockwise direction. So that is the significance of this cross belt drive. So when these pulleys are rotating in one direction, these pulleys that are attached to the other end of the cross belt are rotating in the another direction. Okay. Next, you can see here the pulleys are connected, and you can see these are the straight belt drive or the open belt drive. Okay. So the pulleys that are on the counter shaft will rotate in on the counter shaft, and pulleys at the bottom will rotate both in the same direction. Okay. So these two belt drives are the commonly used belt drives. Okay. So why we are speaking about these belt drives? So during the process of cutting the work material, initially during the forward stroke it will be a cross belt drive, and during the return stroke it will be a open belt drive. Okay. So how to control this cross belt drive as well as the open belt drive? It is controlled by using of a trip dog. Okay. A small mechanism like one is kept here. It is called as a trip dog. So this trip dog controls the cross belt drive as well as the open belt drive. So whenever the forward stroke is taking place, okay, we are using the cross belt drive. Whenever the return stroke is taken place, we are using the open belt drive. So these are controlled by using of a trip dogs. So these trip dogs can these trip dogs move in left and right direction in this figure as shown. Okay. You can see, I will also show you the animation to this counter shaft. A pinion is also attached here. You can see that pinion. To this, on this pinion we are having the work table, that is the rack. Okay. So you know we will see how this I mean the table is should move forward and the reverse. So for you can see the trip dog. The trip dog, when the trip dog is moving from the larger pulley of this blue to red, this is controlled by the trip dog. Okay. The reciprocating of the table is obtained by the cross belt drive as well as the open belt drive, and these cross belt drive and the open belt drive are controlled by the trip dogs. You can see here, if you can see here, those the trip dog is controlling the cross belt drive as a open belt drive. So in order to understand, to make you clear, I have given you here in the diagrams of the cross belt drive and then the open belt drive. So you can see how these are two pulleys and connected by a belt drive in the left side, and in the right side the two pulleys are connected by a belt drive in the straight direction. You can see here, you can see the animation very clearly what is happening in the animation. So whenever in the case of the cross belt drive, so whenever in the case of the cross belt drive, see you can see these two pulleys are connected. When this pulley is moving in clockwise direction, assume this pulley is moving in the anti-clockwise direction. And in case of the open belt drive. In case of the open belt drive, when this pulley is moving in clockwise direction, obviously this pulley also will be moving in the clockwise direction. Okay, this is the pinion. Okay, this is the pinion here. Using this pinion, the table is been moved. Okay, so this is the mechanism of a planar machine. So I hope everyone got this point. So up to now we have discussed the various parts of a planar machine as well as the mechanism of a planar machine. Okay, so now we are discussing how the planar machine works. We have discussed almost the working also. So you can see initially the tool head of the machine is in stationary position and the work table can be moved. We all know that the cutting tool is stationary here and the work table can be moved. Okay, the single point cutting tool is fixed in the tool head and the workpiece is fixed on the work table. As we all know, the work table is in motion. Now we switch on the machine, that means power supply to the machine, and the work table moves forward, hence it cuts the material and it is called as the cutting stroke. Whenever we switch on the machine, okay, we'll be having this cutting stroke, and the work table moves downwards. There is no cutting of the material, so this is called as the return stroke. This is continued unless the you change the power supply or others. Okay, you can see here. So this is the planar machine, this is the work table. So on this work table we are placing our work, and this is the tool. Okay, this is the cutting tool, this is a single point cutting tool. So whenever this single point cutting tool comes in contact with this work, okay, the material is removed. You can see here the material is removed. Generally it is used for making the flat surfaces. You can clearly see here the table is reciprocating and the cutting tool is stationary. But in case of the shaper machine, the cutting tool is reciprocating and the work table is stationary, and you can see the cross belt drive and the open belt drive as well as here. Okay, I hope you got this. Okay, next we are going to discuss about the planar machine operations. The most common operations that can be performed in the planar machine are planing flat horizontal surfaces, planing flat vertical surfaces, planing angular surfaces and machining dovetails, planing curved surfaces, and planing slot and grooves. Okay, these are the various operations that can be performed on the planar machine. Okay, what are the different types? There are different types of planar machines like double housing planar machine, open side planar machine, pit planar machine, edge or plate planar machine, divided table planar machine. Okay, next one and last one is the advantages and disadvantages. So what are the advantages? It have greater accuracy, good surface finish. The major advantages are at a time more than one tool can perform on the workpiece, low maintenance requires comparatively other machine tools. What are the disadvantages? The main disadvantage, the machine price is high, the power consumption is quite more, skilled worker is required, and only tool single point is used. We cannot use other than single point cutting tool. Okay, what are the applications? What are the applications? Planar machine is used for providing flat surfaces on the workpieces. It is used for cutting the angular surfaces. Okay, this is what we have discussed. I am just concluding our lecture. What we have discussed today. What is a planar machine? We have learned. What is the difference between a shaper machine and a planar machine? We have learned. And what are the important parts of the planar machine? We have discussed. And what are the different operations? We have discussed. And what are the types of planar machine? We have discussed. Okay, and we have discussed the advantages, disadvantages, and the applications. Okay, thank you. In the coming section, we'll be discussing another kind of topic. Thank you. Bye bye.